VLSI lab. So let's see how to create 32-bit ALU. Okay, with 8 operations, 4 arithmetic operations and 4 logical operations. So first, that's in the ISC project navigator. Go to file and the new project, and here this is the ALU. Okay, so ALU 32-bit. Click next. Choose the device if you have any hardware devices. Then click next and click finish. Okay, so now click here, right click on this, click new source, Verilog module, and here we need to have ALU. Okay, so here we are just going to do the simulation. We are not using the hardware, so I just do the Spartan 6. Okay, so now ALU module, ALU and AND module. Here we can just change to the simulation. So and ALU, it is a 32-bit, so we need to have the 2 inputs, that is for the input for the ALU. So that is I'm call this as A and B. Okay, so then so first mention the output. One is the output, we need the output. Okay, out or we can simply call this as a Y. Okay, Y is the output. Then we need A and B, these two are the input, and we even need to select the operation. Which operation? Like in 8 operations, to select the operation we need one select line, that is we call this as SCL, select lines. Then we need to have enable. Okay, so enable. So totally there are 5 IO ports, IO input output. After that we need to define here what are all the outputs and what are all the inputs. So for this one, output. Okay, output, what is the output? Y, that is 32-bit, so 32 is to 0 of what are the things, Y and A and B, all these are 32 bits, and we have, okay, so select line, that is okay, so output, and this is we have the 8 operation means, so totally we need 3 bits to represent the 8 numbers. So 2 is to 0, that is 2 bits are required, and we call this as the select line, or we can use simply, okay, instead of select line we use opcode. Okay, OP, opcode. So opcode. Okay, so we just use the opcode, that is the more relevant word. Okay, opcode, because here we are just giving the opcode and it will do the operation. Select line is basically in mux and all we use the select line. Okay, so here Y, instead of this Y we call this as a result. Okay, or any output or anything, this is result. Okay, so then opcode. Okay, so then these two are the output, then input. Okay, so this is not the output, these two are the, okay, so only this result is the output, then input. So 31 is to 0, that is A comma B. Okay, then input, enable. Okay, that is the single bit. Now we have all the 5 these variables we declared here, output and the input. Now we are using the behavioral modeling style, so that's why always block we need to use. So inside the always block, if you want to assign, that means for the output, that has to be in the reg. So reg, so okay, this opcode is not output, it is input, right? Input. Okay, only the result is output. Opcode means we are providing what operations it has to do. Okay, so then reg 31, okay, 31 is to 0 of result. Okay, only this has to be the inside the reg. Okay, so after that always, okay, always whenever these any one of these input, okay, so that means opcode AB enable, in which any one of the change occur, then it has to do. So AB opcode and the enable begin and okay, so we just have all these things in indentation so that it will be more clearer. So here inside this, what we need to do means, so we need to do the operation only if enable is equals to 1, otherwise it should give the high impedance output. So if en equal to 1, okay, then it has to begin and end. Okay, so here we need to write the code, otherwise else the output, so that is result is equal to 32 tick bz. Okay, so that means all the outputs has to be z. Okay, so then here we need to write, so if the opcode, okay, so here we need to write if the opcode is 000 and 001, like that 4 operations we need to write. So we write that in the case. Okay, so here case, okay, so first before that we need to have the switch. Okay, so no, here there is no switch, case only we need to do case. And what is the case, what we need to give? Opcode, case opcode. So inside this, okay, so case and another one is the case. Okay, so this case format is, and here it start with the case and it has to end with end case, end case, end case. And here there should be one default. Okay, so there should be one default the output. Okay, so that is result, result, result is equal to 32 tick b0. Okay, so that is the default value of the result. So now inside this case we have a case opcode, and here we need to have the values, that is 3 tick b000. Then what is the result? Result is equal to a plus b. Okay, so this is one operation. Similarly we need to have 4 arithmetic operations, that is 000, 001, and here it has to be 1 1, and result is equal to a minus b, and here a plus 1, and here a minus 1. Okay, so addition, subtraction, and increment and decrement. So 4 arithmetic operation, and we need to have the 4 logical operations. So for that we just need to make this as 1. So 4 logical operation. So one is the okay, so buffer, that is a equal to result equal to a, that same thing, and result is equal to not of a, that is the not gate or the inverter. Then a and b, logical and a or b, that is logical or. Okay, so there are 8 operations we need to do. Then the default value, then end case. So if enable is equal to 1, then it will consider the opcode. If the opcode is any of these values, it will give us the value like this, otherwise it will give 0. Okay, then end case and end result 32 tick B0. So now save this and okay, so here there is an error. So always A, B, opcode and enable. Always I think we forgot to add H symbol. So now okay, so here if enable equal, okay, yes, now I guess there is no any error. Okay, so we just need to select this and check behavioral syntax. Okay, process completed successfully, no any error. So just remember, first we need to have module ALU, then output and input, then reg always at A, B, opcode and enable, and begin if enable do the task, otherwise result is equal to BZ. And here we need to use the case and the opcode, then 3 tick B00, result equal to these things and default. Okay, so then go here, click new source and click on a Verilog module or Verilog text fixture, directly generate the test bench. Then go to Verilog module and here ALU test bench. So click next, click finish. So here just go to here and just copy these parts. Okay, input and output, this definition part, just to write it easily. So input means it has to be reg. So what are the inputs? 1:2:0 of opcode and another one is reg 31:0 of A comma B and another one is reg n. Okay, so then wire, that is for the output, so that is 31:0 of result, result, result. Okay, so now we can just remove this and this one we just need to have it over here, that is for module our module instantiation. So here ALU and UUT and these things, okay, in the same order. After that we need to provide okay, so the initial and begin. Okay, so begin and end. So what we need to provide? The input test vectors. So for this one initially let's make enable equal to 1 tick B0. Initially enable is 0, then wait till 10, so we should not get any output. So after that enable equal to 1 tick B1 and we need to give A and the B values. Okay, so simply let's hard code the A and the B values. So A equal to 32 tick B. Okay, so this is the 32 tick value, right? So we give in the decimal format 32 tick D and we give as 4. Okay, and B equal to 32 tick D2. Okay, 4 and 2 we are giving. So yeah, now we save this. So there is no any error. Let's check this behavioral syntax. So there is no any errors. Let's simulate this and we will see the output. Why it's giving 0 everywhere? Okay, so we not give the opcode, that's why it's giving 0. So here initially Okay, after this enable equal to 1 tick b1. Okay, so here before that only we choose the opcode equal to 3 tick b000. Okay, so then we choose the a and b. Now uh, we just use the for loop, or anything you can use for just simplicity. Now I just use opcode is equal to 3 tick b 000. Okay, so that is addition. Then after hash 10 we do opcode equal to 3 tick b 001. That is subtraction. Okay, just simply control S and simulate behavioral. Then here we can see the opcode is initially 00. Okay, so then enable is equal to 1 and opcode is equal to 00, and a we have. Okay, so a we have, so here 100 and 10 it is adding. So now when opcode is equal to 001, 100 minus 10, that is 010. So our ALU is working properly. So this is how we can design the ALU. Then after this, so in the EDA, that is the online tool, just it is also the same thing. You just need to just copy down this ALU code in this, and here we need to have the test bench. So ALU test bench, so just copy this and copy that here. After that, before this end module, we need to have these dump waves, and okay, so then simulation time, let's set these tools as LDAV, and here let's choose this for 100 nanosecond, and let's run this. Okay, so before that I will just save this file. So this is ALU 32-bit, and we just save this. Okay, just save this file, and now we can run this. Okay, so I just need to open EP waveform after run. Okay, I need to rerun again. So run. So now okay, so this is some error with this simulator. So just cadence xeriserium, this just choose this and click rerun again. Now it will give the waveform. Okay, so okay, no longer available in the EDA playground to get fresh waveform. So what we do means we just copy the link, and we just paste this link again, and we use the use EP wave after run, and just choose this any one of the simulator and click run. So now we need to get it run. Okay, so it's giving some problem. We just choose some other simulator and just run this. Okay, this is problem with this ADA, I guess. So it has to give. So choose some pre-simulators and let's run. Okay, it will not support Verilog, so okay, so Yes, it's generated. So initially these are all x, that is unknown values. Then uh, the proper, here we can see 0 0 0 like this. We have to see, okay, we have to see the waveform. uh, is showing for till 20 ns. So that one we can increase, I guess. Yes, we can. Okay, so it will run 20. Okay, so it will run 20 nanoseconds, so there is no any time selection option. But here we have the time selection option, so let's make this as a 50n, and we just run this and let's check. Okay, we have the stump dot vcd everything, but it's giving. So we just refresh this. I hope you understood this, how to run in this simulator. We just need to choose this, and here any like okay, so 10 nanosecond, and click run. Okay, so this error with this simulator, just need to choose any other. Okay, so just choose any other simulator and give appropriate runtime and click run. That's it. So it has to generate the waveform. Okay, so save this and run option. Okay, just run this. Okay, sometimes it's not giving the output waveform, but anyway it's fine. We observe the output, right? One time it will come. So yes, I hope you understood this. Thank you.